So in this session, we will discuss the structure questions related to topic circular motion. So Kingda K was the highest roller coaster in the world in 2007. A train initially is propelled along a horizontal track. So the train is propelled along the horizontal track uh, by using the hydraulic system, and it reaches a speed of 57. So at this point, it reaches a speed of 57 meter per second. And from rest in 3.5 seconds. So it starts from rest, start with a 0, and it took 3.5 seconds to reach this speed. It then climbed vertically and falling back towards the ground. So it climbed vertically and then fall back towards the ground. Calculate the average force used to accelerate the fully loaded train along the horizontal track. The mass of the total mass of the fully loaded train is 12,000 kilograms. So we need the average force, or we need force. So F is equals to ma. We have the mass, but we don't know the acceleration. So how to work out acceleration? Acceleration is final velocity minus initial divided by time. So final velocity is 57, initial is 0, and the time it took, that is 3.5. So this will give us the acceleration of this train. And using the acceleration, so it is 57 divided by 3.5. That's equal to 16.28 meter per second square, and we have F is equals to ma. So mass is equals to 12,000 multiplied by 16.28. So we'll get the force, which is 2 into 10 to the power 5 Newton. So in part B, point X is just before the train leave the horizontal track. So it's just before the train leave the horizontal track and move into a first bend. Complete the free body force diagram to show the two forces acting on the rider at this point. So the two forces which are acting on the rider at this point, number one, it will be a weight which is acting downward, and the other one, there will be a normal contact force which is acting upward. So downward force is there, and that's the weight. And we should draw of both these forces equal lengths. The arrow should be the same in size. Why the length of arrow should be same? Because it is in a circle. It's not in a circular track. So when it is not in a circular track, it's moving horizontally. So vertical component of the force, the resultant force in the vertical component is 0. That's why there are 3 marks. 1 mark is for mentioning the normal contact force, 1 mark is for mentioning the weight, and the third mark is to show that these two forces are same. So we should draw these two lines of same length, because the length of this arrow represent the magnitude of the force. So greater the length, greater the magnitude. If two arrows have the equal lengths, it means they have the same magnitude. The mass of the rider is m, and g is the acceleration of a free fall or gravity. Just after a point x, the reaction force on the train on the rider is 4 mg, because now what is happening, it is now in a first bend. So when it is in the first bend, like at this point, so there should be a there should be a force which is directed towards the center. So just about when it entered the first bend, the weight, which is mg, is acting down, and the normal contact force, now there should be a resultant force. Why there should be a resultant force? Because it is moving in a circular path. So whenever object moves in a circular path, there should be a resultant force. So weight is mg, which is acting downward, and the normal contact force is now 4 mg. Show that the radius of a curvature of a track is about 100 meters. So how we can show, or how we can represent, basically the normal contact force minus weight, we can say r is 4 mg, and weight is mg. So R minus W is equals to centripetal force or Fc. What is R? R is equals to 4 mg minus mg is equals to centripetal force, which is mv square over R. When we simplify, we can say 3 mg is equals to mv square over R. M will cancel with m. So we are left with 3g is equals to v square over r, but we need radius, so r is equals to v square over 3g. What is v square? V is the speed at which the train entered the track, that is 57 square divided by 3, and acceleration is due to gravity, so 9.81. So when we substitute these values, we will get the radius of the curvature, which is about 110 meters. Is it clear, this question?
Yes, it's clear.
So before, like, there are two free body force diagram. The first one was when it was there just about to enter. So when it was just about to enter, the weight was acting down, the normal contact was acting up. But when it entered the band, the normal contact force is more than the weight. That's why it creates a resultant force, which is equals to centripetal force. So the next part show that the speed of a train as it reaches the top of a vertical tower is about 20 meter per second. So basically what we assume initially it will have a kinetic energy, and that kinetic energy is transformed into potential energy. So the change in kinetic energy or decrease in kinetic energy is equals to gain in potential, or we can say kinetic energy is equals to potential. Kinetic energy is half mv square and potential energy is mgh. M will cancel with m. So 0.5 v square is equals to gh. If we need height, so it will be 0.5 v square over g. So it will be 0.5 v is 57 square divided by g, the acceleration due to gravity 9.81. So we'll get the value for h. So when we substitute these values, and one more thing, as you can see in part D, we have to show that the speed of a train as it reaches the top. So when it reaches the top, the speed is 20 meter per second. So basically the kinetic energy 1 change to potential energy plus kinetic energy, because still it is moving, so there must be another kinetic energy. So if its speed is 0, because I missed that point, if its speed was 0, then the kinetic energy, like what is the kinetic energy at this point, that will be equal to potential. But because still it is having some speed at the maximum height, so it is also having kinetic energy. So kinetic energy 1 transformed into potential energy and kinetic energy 2. So we can say kinetic energy 1 is equals to potential energy plus kinetic energy 2. Kinetic energy is 0.5 mv square, potential energy is mgh, plus kinetic energy 0.5 mv square. But these two speeds are different because initial speed is 57, and at this point the speed is 20 meter per second, but at this point it is 57 meter per second. So when we substitute, it will be all the m is common, so it will cancel out. So we are left with 0.5. This I can say v1 and this I can say v2. So 0.5 v1 square is equals to gh plus 0.5 v2 square, and then I substitute the value. So 0.5 v1, the initial speed, which is 57 square, gravity is 9.81, vertical height we are finding 0.5, and the new speed is 20 meter square. So when we substitute and solve for h, so 57 square multiplied by 0.5, that's equal to 1624 minus this value 0.20 square multiplied by 0.5, which is equals to 200 and 9.81 in H. So 1624 minus 200, which is
Sir,
1400.
aren't we supposed to show the speed?
It's the same thing because if we consider the height is given 139, so if I solve for height, it will be approximately same because what we have to show that the speed above the train at this point is 20 meter per second. So what we are doing, we are finding, like we are saying that if the speed is 20 meter per second, what will be the height? Or you can solve
So
other
it
way
will be the
around.
same.
Yeah, it will be the same because the height, when we get the height, we should get about 139. So h is approximately 145 meter. You can get the height, so it is approximately, when you calculate the percentage difference, it's less than 10, so you can assume. Or the second way to solve the same question, what we can do, we can substitute this height and we can find the final speed, and the final speed will come out about 20 meter per second. Is it clear, this question?
Yes, sir.
So in this question, the potential difference is then applied and sent to a loudspeaker. Playing vinyl discs LPs have to be rotated about 33 rotation revolution per minute, so that encoded bumps in the groove leads to a correct sound frequency. We have to calculate the angular velocity, so we have to calculate omega. So omega is equals to theta divided by t. So theta should always be in radian, but it is given in revolution. So first what we have to do, we have to convert this 33 revolution. We know one revolution or one rotation is equals to 2 pi radian. So if there are 33 revolutions, then how many pi radians will be there? X cross multiply. So it will be 66 pi radian. So the theta is equals to 66 pi radian. And what about time? That is per minute. So it should be in seconds. So we'll 1 minute is having 60 seconds. So we'll divide by 60. So when we substitute, it will be 66 multiplied by 3.14 divided by 60. That will give us the value for angular velocity, which will be 3.5 radian per second. Then, as the stylus moves toward the center of LP, the encoded bumps must be fitted into a shorter length. Like this is a vinyl disc. Not common now, these vinyl discs, but it was there used to play the music. So what they're saying as the stylus moves toward the center of LPs, the stylus means this part which is placed on this disc. So these grooves which are there, the encoded bumps must be fitted into a shorter length of group. So this should be a shorter length of the group compared to when the stylus is moving away from the center. Explain why the encoded bumps in the group become more compressed as the stylus moves towards the center. Look, as the stylus is moving towards the center, it should produce the constant frequency, or it should, because otherwise if the frequency change, then the sound and the sound will also change. So what we want the same angular velocity, or we want this to complete the time, to complete rotation in same time, because if the rotation is about 33 revolution per minute, so when it is moving away from the center and when it is moving toward the center, both cases what we want, we want it to complete the 33 revolution per second or have a same angular velocity, even it is closer, the stylus is closer to the center or stylus is away from the center. So first thing we'll mention, the frequency or the time period or angular velocity should remain constant. So when we have this formula, so otherwise the frequency completely change, the sound produced, so omega, the frequency or the time period must remain constant, should not change. So this is a shorter length, as you can see this is a shorter length. So we have the formula for circumference, c is equals to 2 pi r. So circumference is equals to 2 pi r, and we know v is equals to r omega is there. So the stylus move towards the center, the linear speed or the velocity or the rotation, this r is getting smaller. So basically what happened, as you can see, when it is moving closer to the center, the radius will, that's basically the circumference decrease. If the circumference decrease, the radius will decrease as well. And if radius will decrease, we have this formula v is equals to r omega. Omega is constant, so if radius is decreasing, the tangential speed should also decrease. So it should move slower here. So to move it slower, that's why these grooves are placed closer to each other compared to the grooves which are placed. The number of the grooves are same, but the grooves are placed closer. So what it will do, it will slow down its tangential speed. Is it clear?
Yes, sir.
So in short, we want same angular velocity. So if we want same angular velocity, radius is decreasing, so the tangential speed must decrease. And how the tangential speed could be decreased? By changing the distance between the grooves. They are more compressed, they are closer to each other, so it will have it will slow down the tangential speed of the stylus as compared to when it is away from the center. In this question, the London Eye consists of a large vertical circle with 32 equally spaced passenger cabins attached to it. The wheel rotates so that each cabin has a constant speed of 0.2 meter per second and move in a circular track of radius 61 meters. So the which we have to calculate the time. So the tangential speed is given, the speed at which this cabin is moving, that is 0.2 meter per second. 0.26 meter per second. So V is given, R the radius is there, which is about 61 meters, and we have to calculate a time for each cabin to make one complete revolution. So for one complete revolution, we know that speed is equals to distance divided by time. So the speed is equals to distance divided by time. The distance travel will be equal. So speed is v. The distance travel will be equal to the circumference, which is 2 pi r, and divided by time. That is, we are finding the time period. Because when object move one complete rotation, the distance travel will be circumference. So time is equals to 2 pi r divided by t. So it will be 2 into 3.14 into 61 and divided by v, not t, and the v, that is 0.26. So we'll get the time period, which is 1473 seconds it will take to complete its one revolution. Is it clear, this part?
Yes, sir.
Then the second part, we have to find the force. In part B, we have to calculate the force acting on each cabin. So basically the centripetal force, the mass of the cabin is given. So Formula for centripetal force m v square over r. So we have m, we have v, and we have r. So we just have to substitute the value. 9.7 into 10 power 3 kilogram is the mass. The speed is 0.26 square, and the radius is 61 meters. So we'll get the centripetal force in Newton, which is about 11 Newton. So in part C1, the diagram shows just the circle and the cabin. Draw an arrow to show the direction of centripetal force on a person when the cabin is at position A, B, or C. So centripetal force is always directed towards the center. So all the cases, the centripetal force will be there towards the center. As the person as the person in a cabin moves around the circle, the normal contact force between the person and the cabin varies. State the position at which the force will be maximum and the position at which the force will be minimum, and explain your answer. So the person who's inside this cabin is experiencing a normal contact force. So we have to identify which position the normal contact force is minimum and which position it will be maximum. So it will be maximum. Basically what happened, because the weight is acting down, because we want the resultant towards the center, so the normal contact force should be, the resultant force should be there towards the center. So it means the upward force at point C, the upward force should be higher than the downward force, so that the resultant which is created by these two forces, that is directed towards the center. And same way at point A, the weight is acting down, so the normal contact force which is acting up. So what will be the result here in this case? Because we want the resultant towards the center, so resultant should be there which is directed towards the center. So as you can clearly see, because to create a resultant towards the center, for position A the normal contact force is smaller, but for position C the normal contact force is higher. So red arrow is representing the weight and the black arrow is representing the normal contact force. So here the normal contact force must be greater than W at point C, but at A the normal contact force should be less than W, so that it will create a resultant force towards the center. So we can say at C the normal contact force will be maximum and at A it will be minimum. So first the maximum, it will be maximum at C and it will be minimum at A. And when we write the equations, the resultant force, equation for the resultant force at C and at A. So when we write, so R is acting up, so R minus W should be equal to centripetal force Fc, or we can say R is equals to W plus Fc or Fc plus W. So means the normal contact force should be a sum of weight plus centripetal. But at A, it will be weight minus R is equals to centripetal, or we can say R, because R move other side, Fc will come here. So weight minus centripetal force should be equal to R. So one mark you will get when mentioning it is maximum at C and it is minimum at A. That is one mark. Then you will mention this equation. This equation that is the second mark, and this equation, that will be the third mark. And what is the last point? You should always mention that there, when it is moving in a circular path, so there should always be a resultant force. There is always a resultant force towards the center. Is it clear?
Yes, sir, it is.
Okay. So this is the last question for discussion today. Next session we'll do more questions and start new topic which is about momentum.